Welcome to 7.5 Application of Rational Equations. Today we're going to apply solving rational equations to real life scenarios. And we break this down into three types of questions. The first one is going to be our combined rate problems. And those are based on a formula 1 over a plus 1 over b is equal to 1 over t. Now this 1 over a is going to represent one person doing one job in a amount of time. We combine that with someone else, one job, how long it takes them to do it, to get, if they were to do it together, it would take them T amount of time to do one job. Now, what's going to happen is you're not going to be changing the numerators. You will adjust the denominators to reflect how long it typically takes a person to do whatever job your question asks of. So for number one, Yasmin can paint a fence in 8 hours. So she can paint one fence in 8 hours, one job. Jeanette can do it in 4 hours. So she paints her one job in 4 hours. How long will it take for them to do the job if they work together? So if I take each of their individual rates and I combine them, what is going to be their combined rate? So we are going to approach these problems just like we did our regular solving rational equations problems. I'm going to get a common denominator first. So I'm going to get my common denominator of 8t. So my first fraction needs t in the top and bottom. My second fraction needs 2t in the top and the bottom. And my third fraction needs an 8 in the top and the bottom, which is going to give me t over 8t plus 2t over 8t is equal to 8 over 8t. And now when we were solving rational equations, we canceled out our denominator by multiplying the whole thing by that denominator. So that allowed us to say every denominator gets canceled out and I'm left to only deal with the numerators. So that's going to give me 2 or t plus 2t is equal to 8. Combine my t's, I get 3t is equal to 8. Solve for t, and I get t is equal to 8 over 3. Well, they do ask us how long does it take them to do it, and I can't really say it takes them 8 over 3 time. We do want to convert this to hours and minutes. So I'm going to write this so that it's written as 2 and 2/3 because 3 goes into 8 twice with 2 left over. So this is going to represent 2 hours and 40 minutes. Now, I got 40 minutes because 1 hour is 60 minutes and 2/3 of 60 is 40. So let's go ahead and look at number 2. Tim can stuff envelopes 3 times as fast as his wife, Jen. They have to stuff 5,000 envelopes for a fundraiser. Working together, they can complete the job in 4 hours. How long would it take each of them if they were working alone? So let's kind of process what they are telling us. They have to stuff 5,000 envelopes for a fundraiser. Now, I don't want you to get confused by 5,000. 5,000 is still just going to be one job. The entire job is all 5,000 envelopes. We are not going to change the numerator. So that one job, if they were to do it together, they can complete it in 4 hours. One job, 4 hours. Now, what about individually? Well, Tim can stuff envelopes 3 times as fast as his wife, Jen. So let's say one job, we're going to represent Tim's time by A. So 1 over A. Now, Jen takes longer. She's going to have to work 3 times longer than Tim since he happens to be faster. So her statement is going to be written as, let's pull it up, 3A. So one job, it takes her 3 times as long as Tim to do it. Another way you could write this is 1/3 A and A. Personally, again, if I can avoid working with fractions, even though I'm working entirely with fractions, I will try to do that as much as I can. So let's go ahead and give them all a common denominator. Common denominator is going to be 12a. So I add in a 12 over a 12, a 4 over a 4, and a 3a over a 3a to give me 12 over 12a plus 4 over 12a equals 3a over 12a. Going to multiply through by my common denominator so that I can cancel my denominators and end up only with my numerators. That's going to give me 12 plus 4 is equal to 3a. 16 is equal to 3a. A is equal to 16 over 3, which is equivalent to 5 and 1/3. And if we said that 2/3 was 40 minutes, well, 1/3 is going to be 20 minutes. And remember, A is representative of Tim's time. So Tim can, if he was doing the job, all 5,000 envelopes by himself, would do it in 5 hours and 20 minutes. Jen, she has a little bit rougher of a time. Remember, she's represented by 3a. So I'm going to do 3 times 16 over 3, which is going to give me 16 hours. Jen's going to be working a long time if she's doing it by herself. Another type of problem that you may encounter is a problem of averages, and it's where we want to increase values in the numerator and denominator to reach a certain percentage. So a college basketball player has made 58 out of 82 attempted free throws this season. How many additional free throws must she make in a row with no misses to raise her free throw percentage to 80? So she's trying to get 80 out of 100. That's the percent she wants. And she needs to make additional free throws in order to do that. So we're going to increase her numerator, but also because she's increasing the amount that she makes, we have to increase by the same amount her attempts. So I added plus x in the numerator and plus x in the denominator. Now that I have my rational equation set up, I'm going to go ahead and approach it as we do every solving problem. I'm going to give it a common denominator, 100 on the top and bottom for my fraction on the left, 82 plus x on the top and bottom for the fraction on the right. Going to work through and clear my denominators by multiplying by the common denominator, leaving me with just my numerators. So that's going to be 5,800 because I am distributing. Do not forget, the 100 goes to the 58 and to the x, and the 80 goes to the 82 and the x, giving me 5,800 plus 100x is equal to 6,560 plus 80x. Move all of my x terms to one side and my number terms to the other, and I divide. So something you can also do, a little trick, both of these end in 0, so really it could be divided by 10 and they kind of cancel each other out, and I end up with, instead of dividing 760 by 20, now I'm dividing 76 by 2. So x means that they need to make 38 free throws in order to get that free throw percentage up to 80. Now we are going to move on to our distance, rate, and time problems. So one thing that we have to really focus on is the formula in this instance, and the formula is distance is equal to rate times time. Now, that is the general formula. The formula we work with the most, if I were to divide on both sides by r, I end up with t is equal to d over r. Time is equal to distance over rate. And generally, with these problems that you are given, this is what you will be working with. So what we're going to do, we're going to sketch out a distance, rate, and time table. It's the easiest way to organize the information you have. I highly suggest you do it because it's going to help you solve the problem that much quicker. So, number 4, Jesus can jog 5 miles downhill, that's his distance, in the same time it takes him to jog 3 miles uphill, that's his other distance. So I have 2. He jogs downhill 4 miles per hour faster than he jogs uphill. So I'm going to call his rate when he's jogging downhill r plus 4, and I'm going to call his rate when he's jogging uphill r. Now we want to find his jogging rate each way. So what we're going to do is we have something important that we need to highlight. He travels both of these distances in the same amount of time. So I'm going to call his distance for downhill T1 and his distance for uphill T2. And if he's doing it in the same time, then T1 must be equal to T2. And remember, I said we focus mostly on this formula. I'm going to create a equation for his downhill journey and his uphill journey. So let's go ahead and do that. T1 is his distance of 5 miles over his rate of r plus 4. T2 is equal to his distance of 3 miles over his rate of r. And we said that these two things are equal to each other because he does them in the same time. So that's what I am going to work with. 5 over r plus 4 is equal to 3 over r. Now, we have an equation. We're going to go through the process we've been going through. Give them a common denominator. So r over r on the left side, r plus 4 over r plus 4 on the right side. And then I'm going to take the fact that I've created a common denominator and cancel out all of my denominators. So I multiply on both sides to get rid of the denominators entirely. That leaves me with 5r, 5 times r, is equal to 3r plus 4 times 3 is 12. Move all of my r values to one side. 2r is equal to 12. R is equal to 6. Now, don't forget in the end that you have to actually answer the question. It wants his jogging rate each way. So R is equal to 6. So that means uphill he's going 6 miles per hour, and his rate when he's going downhill is R plus 4. That means he's going 10 miles per hour when he is jogging downhill. So let's go ahead and look at another problem like that. A passenger train travels 392 miles in the same time. So let's go ahead and start organizing information as we read. Passenger train, 392 miles is the distance. We know we are also going to be dealing with another problem where they have the same time, that it takes a freight train to travel 322 miles. The passenger train travels 20 miles faster. So I'm going to call that R plus 20 and R, then the freight train. Find the speed of each train. So again, we know that it's the same time. T1 is going to be equal to T2. I do want to say that if you were to write your rates for problem 4 or problem 5 and have the rate that's going slower written as r minus 20, and then this would be r, that is also the same thing, and it is okay. We will get the same result as long as you are doing your algebra correctly. Now I'm going to go ahead and set up things as I did before. T1 is going to be 392 over r plus 20. T2 is going to be 322 over r. Going to set these two things equal to each other because it happens in the same time. Going to give them a common denominator, r over r, and r plus 20 over r plus 20. Now that they have a common denominator, I can cancel that denominator out, leaving me with just my numerators. So that's going to be 392r is equal to 322r plus 6,440. I know, seems like big numbers, but we're going to move everything around. So I get 70r is equal to 6,440. Now remember our trick, if they all end in zeros, we can simplify a little bit by technically dividing by 10. And here I just went ahead and did some long division. I divided 644 by 7 and I got 92. So R is equal to 92. And remember, R is representing the speed of our freight train. So let's go ahead and answer the question because they asked, find the speed of each train. So my freight train is going 92 miles per hour, but my passenger train goes 20 miles per hour faster. So that's 112. So here is my final answer. Okay, last problem. A river barge travels at an average of 8 miles per hour in still water. So this is going to be slightly different than what we've done previously. However, it is still a distance, rate, and time problem. So we are going to now have a base speed. If there were nothing happening, this river barge is going 8 miles per hour. So the barge travels 60 miles up the Mississippi River and 60 miles down the river in a total of 16.5 hours. What is the average speed of the current? So that is something that we are trying to find. We're not trying to find the speed of the boat or the barge in total. We're trying to find the specific speed of the water current in this section of the Mississippi River. Now, what's going to happen is you have to understand the concept of upriver and downriver. If you are going upriver, you are working against the current, meaning your speed is going to slow down. That's why I have it represented as the 8 miles per hour minus the speed of the current. If you're going downriver, you're going with the current. Therefore, it's increasing your speed. So I have the base speed of 8 plus the river current. So now we have to determine we're no longer dealing with the type of questions where it's the same amount of time. Now we know it's a total of 16.5 hours, which my times need to get filled in. So T1 plus T2 is going to equal to 16.5. So I went ahead and created my equations. 60 over 8 minus C plus 60 over 8 plus C is going to equal to 16.5. Now I need to create a common denominator, and this one's a little bit different again. So because I have two different denominators entirely, I do need to perhaps rewrite 16.5 a little more than I have in previous problems. So first denominator, or first fraction, is going to get that A plus C. Second fraction is going to get the A minus C. The third fraction is going to get the A plus C and the 8 minus C. Now that everything has a common denominator, I'm going to go through and multiply by that common denominator in order to cancel out all of my denominators and leave me only with the numerators. Now remember, we are dealing with multiplication, so you have to remember to distribute. So this 60 is going to distribute to the 8 and to the C and to the 8 and to the negative C. Here we'll do a little bit more work with it. Now, one thing I do want you to know, it says round your answer to the nearest tenth. So I'm going to imagine anytime you read that, it's a problem where you can use your calculator. So we will use our calculator in the end, just for this one particular problem. So I end up with 480 plus 60C plus 480 minus 60C is equal to 16.5 times 64 minus C squared, because this is a difference of squares. So I'm going to kind of simplify this a little bit more. My 60C's are going to cancel out, leaving me with 960 is equal to, I went ahead and distributed my 16.5. And yes, this one's okay if you use a calculator. 960 is equal to 1056 minus 16.5 C squared, which if I move all of my number values to one side and my variable to the other, I get 16.5 C squared is equal to 96. I'm going to divide on both sides by 16.5 using a calculator, and that's going to give me C squared is equal to 5.8182. How you round is okay. You're going to be in a safe area for getting it correct, especially because if you were to see a problem like this on a test or a quiz, I will be looking at your work more than I will be looking at your final answer. So now in order to get my C by itself, I'm going to take the square root of both sides. Now generally, yes, we would take plus or minus. However, we know that a current cannot have a negative speed, so I'm really only focused on the plus. And it's going to be C is equal to 2.4 miles per hour. So the current of the Mississippi River in this section is 2.4 miles per hour.